While you settle into the dark, a handful of satellites cross the sky above your roof. Top of the world to the bottom, they pass, and you will never see them. Far above your room, the first polar arc has already begun. This is the Night Almanac, your home in the dark, with nothing to do and nowhere to be. Tonight you drift far out, past the room, past the city, to where the world goes quiet, and home by morning. Sleep whenever you like. That arc belongs to NOAA's Joint Polar Satellite System, or JPSS. The fleet traces a line from northern to southern ice, while the ground slides beneath it. The satellite keeps meeting new terrain on each crossing, with cloud and water lying deep below. A polar orbit carries the spacecraft over both ends of Earth. It is a route made for the planet that rotates beneath it. The craft crosses one long arc, then another. Under that arc, the shadowed half keeps yielding fresh ground to the same measured sweep. The orbit is easy to follow, distant past any need to hold on. No road lies under the window, the line rides in the upper air. It crosses places your feet will never need to walk, while the route opens above weather and ocean. The pane falls behind, and the roof becomes only a lower edge. Full global coverage comes from the polar path and the planet turning under it. The spacecraft keeps crossing while Earth brings up new ground. Twice each day, the coverage can close around the globe. The idea is large, but the motion is simple. A line above, a world wheeling under it. Each crossing lays down another strip next to the last one. Pass by pass, one satellite swath meets the next, and the strips add up into full coverage. Blue-white tracks settle side by side over ocean and ice. You leave the remembered room behind by almost not thinking of it. The town beneath loses its edges in cloud and distance. Familiar roofs become faint geometry, then only a scattering of dim points. The orbit has no walls to arrange your attention, so the mind can rest on the curve. A weather satellite does not stop watching once the sun goes down. On a polar fleet crossing, it can catch moonlight thrown back from ice instead of daylight. The sheen is borrowed and thin. It lies over frozen ground as a pale glint on the ice. One such example was caught in February 2025 over Lake Erie by the Visible Infrared Imaging Radiometer Suite, reading its day/night band. What remains is the same low-light instrument, still doing its ordinary work of watching Earth's surface, now turned on winter ice after sunset. That data told lighter ice from black open water after sunset. Frozen crust and liquid answered the moon differently, bright beside dim, still night. The scene stays at lake scale. The subject is a winter expanse, wide and broken, under reflected moonlight. The satellite can hold moonlit ice and dark water in one calm frame, with the shoreline left unlettered and a long way down. You float over the frozen surface as if the window has risen into the sky. The bed has slipped from the center of the frame. Ice beneath gathers in broken plates and smoother fields. Open water interrupts it in wide black shapes, and the satellite's track continues past the shore. The moonlit ice stays useful because the crossing is reading a weak return. Afternoon glare is absent. Only a thin gleam rises from the ice sheet into a sensor built to keep noticing after sunset. Open water gives back less moonlight. That difference is why the ice can stand apart in the data. Under the track, a lake becomes two calm materials, one returning a brighter signal, one holding more black. Between the ice plates, the lake keeps its own unhurried geometry. Some edges look torn. Others curve as if pressed into place by the season. You do not need the exact shoreline. The satellite has already drawn the line between ice and water, and the crossing goes on past the frozen lake. The separation stays remote from you. Nothing asks to be read at the bedside. The lake beneath can be ice beside water, bright beside dim. You keep moving with the orbit, as if the whole winter shape is sliding under a glassy rail. A winter lake from orbit has no household scale. The bright fields do not become rooms, and the black openings do not become streets. They stay an expanse under moonlight, wide enough to loosen thought. The orbit keeps carrying the weather satellite past the lake, back toward the clouds. The night imager's day-night band detects very faint sources after sunset. Within that range are city lights and gas flares, fires and lightning, reflected moonlight and auroras. Each source can stay only a trace on the planet. City lights can appear as fine points within that low range. The detail stays distant, losing street names and corners. A coastline may hold a loose necklace of white, while inland ground fades into broad, unlit shapes under the quiet orbit. Gas flares can also sit inside the band's reach. From the satellite track, a flare can be one clean point on a vast plain. Fires and lightning belong to the same faint family. The words stay factual and distant. A lightning thread may cross a cloud top as white, while the rest of it stays a broad, blue-white cover under the sensor. Reflected moonlight and auroras finish the faint source list for this crossing. One can lie on ice. The other can hang near the polar edge as a green-blue veil. This band accepts both without asking darkness to become day. That thin reach can hold many kinds of source. The sensor does not make them loud. It receives them as signals from a planet half turned from the sun. City grids and flare points stay deep under the orbit. Ice shine and aurora sit in one wide field. You move through those sources as a sleeper moves through distant sound. Pinpoints and green-blue veils slide beneath. None becomes a task. They only show that the shadowed side from orbit is full of different kinds of weak signal. That band turns weak illumination into observation. The unlit half stays observable. It gathers sources that are dim or reflected, then gives the satellite a way to look after sunset. You let the sources flatten into one broad field. Their names no longer need holding apart. They become white grains and green-blue curtains under the orbital crossing. Attention loosens because the sensor is doing the sorting. A faint source in this frame stays small, quick to slip by. Rather than a summons from the ground, it is a mark inside the instrument's range, distant from your room and from any story beneath. The orbit gathers it, then leaves it in the wider field. Ahead, the planet looks less like a place to enter. It widens into a broad expanse under a sensor. You are well past street corners now, and well past any single window. Attention can spread until one pinpoint is no more demanding. NASA black marble nighttime light products are derived from the same night imager aboard Suomi NPP, NOA Amanus 20, and NOA Amanus 21. That instrument supplies imagery of the planet after sundown, a picture of the unlit side. Black marble uses low-light imagery of the shadowed hemisphere. The product begins with readings from that faint band, gathered by polar orbiting satellites as the planet turns under their tracks. A global picture can form from many night-side crossings. The 3 source spacecraft give the nighttime record its origin in the night imager. What remains is a black-blue globe, stippled with settlement lights and shore shine. This product's subject is the unlit hemisphere, seen from a distance that turns it into pattern. It can hold settlements as silver dust and coasts as thin edges. No address is the point. The frame keeps the planet wide and remote. It is easy to move over. You are high above the old pane now. The lights beneath make no invitation. They are marks on a globe, held at a distance, built for sleep. The nighttime record keeps the subject at planetary scale. It can show where light gathers, while leaving the ground unreadable as a lived place. The expanse looks polished and remote, scattered with pinpoints that belong to no story you need to follow. That faint band gives the product its origin. A city edge or moonlit crust can join the same unlit picture. The image feels smooth because the measurement has already done the sorting. From this height, a settlement is less an address than a grain of light. The old room has thinned to memory. You keep floating over coasts and interiors. The places are too distant to name, and the night map grows wider beneath you. The scene of lights has grown too wide to name. It has shorelines without signs and interiors without borders. You move above it as over a black cloth pricked with silver grains. Black Marble products provide daily and monthly nighttime composites, and a yearly record as well. A night-side reading can join a longer archive instead of staying one isolated picture. The crossing still happens overhead, but the result can belong with others after Earth has turned again. Daily composites hold the nearest rhythm in that sequence. They gather that light into a frame that belongs to a day, not to a single strip alone. The image can feel continuous, though it began as separate thin readings. Monthly composites widen the span. The separate traces can settle into broader patterns, less like sparks and more like a field with texture. A coastline becomes a lasting edge of light, while oceans keep their wide, near-empty reaches. Yearly composites widen it again. Night light can be held across a longer record, so the passing reading joins a slower archive. The longer record changes the feel of a crossing. It is still one movement through the upper air, yet it can settle among the others. A single point beneath does not have to stand alone. It can join a wider nighttime composite. You move past the idea of a picture. The path feels more like a measured crossing than a photograph. Beneath you, lights gather into patterns too large to visit. Above, the spacecraft goes on, and attention can travel with it, unhurried and unclaimed. The composite products turn thin readings into longer records. Each span can carry a different amount of the night world. The facts have widened, yet the image stays simple, Earth lit from its own darkness. The record stays deep beneath you. Passing light can be kept without becoming a stack of tasks. The track goes forward, and the many readings can lie together like thin panes of glass, each one holding a little of the night. The stored frame has no hurry in it. A single crossing can leave its trace, and other crossings can rest beside it. You float above the layered result, with the planet turning under the stack in slow silence, and the track moving on. The night imager's moderate spatial resolution is 375 meters per pixel. That gives the polar orbiting scene a concrete scale. The image stays well above the ground, a measured grid laid over Earth from a great height. NOAA calls that scale moderate spatial resolution, a coarse measure that keeps whole fields inside one square. A 375 meter pixel sits in the distant scene. It is a square of observation, so wide it loosens the body from scale. You are not inside it, you are above it, where the ground becomes a pattern that asks for nothing more. The moderate resolution keeps the polar scene at survey scale. Lights can gather into fields rather than addresses. Ice and water stay broad expanses under the track. Cloud fields keep the same distant scale. That pixel scale gives the night a measured boundary. One expanse may separate from another, yet the frame stays broad. The satellite is not close enough to enter a room. It keeps the Earth at a distance fit for weather and night light. You move from image into measurement, from moonlit crust into gridded Earth. The change is gradual. Attention narrows by degrees, from a lake scene into a pixel, so broad it belongs to distance. At this scale, the planet can be known without becoming near. The grid has room inside each square for ground you cannot enter from orbit. That distance is part of the ease. A weather satellite can measure an expanse while leaving it broad and remote. The spacecraft still crosses the shadowed half of Earth. The eye has had its low-light pictures. Now, the same crossing begins to feel like a set of senses, some visible, some hidden, laid over cloud and air. The advanced technology microwave sounder observes in microwave wavelengths. This sensor is not reading moonlit ice the way the night imager does. Microwave wavelengths let the sounder see through the clouds. A cloud top can close the scene for visible light. The microwave reading can still carry word from the atmosphere under and within it. From above, the white layer gains depth. What looked like a flat lid becomes a slow thickness, shadow pooling in its lower folds. The white shield sits in soft ranks below, unhurried, giving the eye no edge to catch. The microwave scan complements infrared instruments. It adds another way to sense the atmosphere when cloud stands between the ground and the satellite. Because that instrument works in those wavelengths, a cloud sheet can become part of the measurement. The visible ground may look sealed from above, while the microwave path belongs to a deeper reading of air under and inside it. You move over cloud now after the ice. The scene is a white cover stretched across the planet. Above it, the instrument does its work, while attention can stay loose on the orbit and the curve. Microwave sensing can reach through cloud and complement infrared. That keeps the white shield from being a stopping place. In the distant scene, the atmosphere gains depth under it. The cloud deck below has no edge to solve. It spreads beneath the orbit in blue-white folds, with breaks that open into lower shadow. You stay above it, carried by a measurement that reaches where sight would stop. Cloud from orbit becomes an expanse you can leave unopened. The instrument works in a range your eyes do not share. Under the white cover, air still has structure. You move over it without strain, held well above the hidden depth. Microwave and infrared instruments are useful together because they sense different parts of the atmosphere. One works in microwave wavelengths. The other belongs to infrared measurement. The microwave and infrared pairing gives the crossing a layered way to know air. One signal has the cloud advantage. The other carries its own infrared detail. From the spacecraft, the atmosphere stops feeling like a lid and starts to read as depth. The crossing has moved from reflected moonlight to weak sources, then from gridded night light to cloud-piercing measurement. Nothing has sharpened into urgency. Each method is one more way for the planet to be sensed as the polar track goes on. The cross-track infrared sounder provides detailed vertical observations of atmospheric temperature and moisture. The infrared sounder looks into the air in layers, rather than as a flat picture. Above the night, the atmosphere becomes a tall structure, measured through warmth and water vapor. Cloud gives way to thin stacked levels, each a little cooler or damper than the one beneath it. That instrument uses 2,211 infrared channels. Instead of one broad infrared note, it separates the signal into many narrow bands, together reading the atmosphere in detail from above. Data from the infrared side are combined with the microwave scan for atmospheric profiles. The infrared layers and the microwave path meet in one larger result. Temperature and moisture are arranged by height, so the air under the satellite becomes a vertical structure. Atmospheric profiles turn height into order. Warmer and cooler layers occupy different levels. Moisture can belong higher or lower in the column. You float beside the layers as if the air itself has become a slow page. There is no line to read aloud. There is only height from cloud top to upper air, with the orbit carrying the whole measurement onward. Those profiles are the result of combining infrared and microwave readings. The fact stays technical, but the image can stay simple. A column of air is sensed in layers, while the turning Earth beneath keeps offering the next stretch of atmosphere. The infrared instrument supplies one side of the pairing. The microwave side adds the other. Together, their data support profiles rather than a flat night picture. The crossing is still overhead, but the subject has risen from surface light into air. The night now has a vertical grain, thin bands stacked from cloud deck up into thinning air. The infrared side and the microwave side meet without turning dramatic. They only arrange the air into layers a satellite can use. From your distant place beside the track, the column looks less like a problem than a stack of blue-white, receding distances. The measured column can simply travel with you. Its lower reaches touch cloud. Its higher levels thin toward space. The spacecraft keeps crossing above the turning planet, and the air beneath keeps its order without needing to be held in the mind. The spacecraft has carried you a long arc beyond the bedside scale. Moonlit ice and faint points have gone by beneath. Now cloud and air have taken over the scene. Each subject has moved farther from the room. Each one is easier to leave alone as the orbit goes on. The bed is a small, warm memory now, far behind the slow turning of the planet. The polar track still repeats over the turning planet. That fact has become background now, less account than emotion. A blue-white line slides above the world. Earth keeps bringing weather and darkness under it. The old window is behind you, but it has not vanished. It marks the first point on the long outward path. Ahead, the long arc has room to continue. You stay carried by distance and by the unhurried curve of Earth. High-rate data from the fleet leaves the satellite as a continuous X-band downlink, carrying science measurements toward compatible receiving sites. You follow the signal downward, away from the earlier night track, while Earth below becomes snow-dark terrain. The beam is no longer only a line above the weather. It is a working path for measurements, crossing the upper air toward a place made to catch it. Below the pass, snow and rock hold still under a wide polar sky. You are farther from the room now, carried along the same invisible line. The receiving place waits ahead without a human story attached to it. Its work is shape and timing, held under blue-black air. Direct broadcast means the science stream can go straight to sites built for that path. A satellite crosses overhead, and the receiver chain below has already been arranged. The conversion stays physical and low. A dish points. Sheltered electronics take the radio signal in, and the measurements begin to become usable inside a low-lit room. Compatible sites are the places prepared for this stream. From above, the route narrows toward a metal circle, then into cable and equipment. The air between is empty to the eye. Still, the path has a direction, from spacecraft to antenna, from antenna to the first protected box. High-rate data carries science measurements, so the downlink is more than a beautiful trace. It is the practical version of the night-side crossing. The stream leaves the spacecraft as radio energy, then reaches hardware that can understand it. You move with that change, from wide sky into the first narrow opening below. NOAA Amanis 20 high-rate data is listed at 15 Mbps, and NOAA Amanis 21 high-rate data is listed at 25 Mbps. The figures are modest beside the distance. They cross. They belong to weather instruments moving over polar terrain, sending a measured stream downward. In the receiver shelter, the rate becomes a run of bits, arriving through chilled air. You can let the figures pass without holding them. They move through the line like beads through wire, one after another. The spacecraft has already crossed farther on. Behind it, the station keeps the shape of the pass. For a little while, the sky seems to leave a clean groove in the equipment. The two downlink listings belong to the two named spacecraft in this weather series. Each name has its place in the stream. Each one carries its own listed rate. Outside, The high-latitude night receives them as separate overflights, spaced by orbit and the turning Earth below. Those listed rates become less like numbers once they reach the rack. They are the pace at which science measurements can enter the sight system. A bright display is unnecessary for the thought. The stream can be held as a narrow, ordered flow, moving from radio path to circuitry in the low room. A direct broadcast chain is a set of parts, not a grand object. The route comes down to hardware in a practical order. Metal and cable take over from sky. Inside the shelter, a bench or rack can hold the pieces that make the stream usable. A typical direct broadcast user station for that fleet includes an antenna, a low noise amplifier and down converter, a demodulator, and a processor. The chain begins in open air and ends in computation. Between those ends, the incoming signal is kept orderly, like a narrow thread drawn through a clean sequence of parts. The antenna is the first named piece in that user site. It gives the arriving X-band signal a physical doorway. The rest of the chain can sit lower, behind a wall or inside a rack. A cable bend becomes the next section of the route, leaving the sky for the shelter. The feed area makes the sky feel almost mechanical. The antenna is passive here, but its shape gives the overflight a landing point. The low noise amplifier and down converter sit early in the radio route named in the equipment chain. Their place is near the first captured energy. The technical words settle into a sheltered metal box, fixed along the line from dish to rack. Chilled air gathers on the housing, while the path turns inward. The demodulator comes later in the same direct broadcast chain. It receives the prepared X-band stream and pulls usable structure from it. Then the processor can handle the science measurements after the carrier has been shaped for it. In the rack room, this step is another graphite unit among other low lights. The processor is the last named piece in the typical user setup. After antenna and radio hardware, it holds the stream in a usable form. Its face does not need words for the eye. Sparse pinpoints suffice, set into dark metal like distant windows. You move near the chain, then outward again. The hardware rests near the terrain, while the spacecraft moves through a much wider curve. This contrast is easy to keep. A modest dish below, a moving satellite above. Between them, a radio path that has become almost touchable. NOAA notes that many direct broadcast user antennas are 2.4 to 3.7 meters across. The dish is wide enough to matter, yet still human-scaled beside a shelter wall. Under polar light, the rim becomes a clean circle of metal, raised toward a source that will not stay still. That antenna span is large, a size the body can understand. It could stand beside a service hut and still feel contained by the landscape around it. The rim stays far below observatory scale. It remains a practical receiving surface, the right kind of metal circle for a passing stream. An antenna in that range can stand on a short mast or beside a squat shelter. It stays modest against the horizon. It is practical capture hardware, its width sized to gather the moving stream. Around it, the land can stay open and wind-brushed, marked by drifts without any counting. The rim falls behind as you move across the polar surface arc. The land opens again, and the facility becomes a cluster of low shapes. A few point lights show where the signal path enters. Nothing flashes for attention. The contact is allowed to be a measured event, then a memory in the gear. Many user antennas fall within that few meter span, so the broadcast idea stays close to reachable hardware. A compatible setup can be built around an antenna and equipment chain. The view remains sparse: metal coaxial cable and a protected room under a high blue-white sky. Field terminal support for the fleet provides orbital data, including 2-line element sets. Direct broadcast users can locate and track satellites before an overflight arrives. The crossing is not guessed from the sky at the last moment. Its route is prepared from numbers carried ahead of it, like a line already drawn over the night. The provided orbital data gives the receiving site a direction before the spacecraft appears. A dish can begin from an expected path. The sky looks unchanged, while the geometry has already been worked out. Far along the route, the incoming contact feels scheduled by mathematics rather than urgency. The tracking purpose is simple. The site needs the satellite's path before contact. A dish can meet that crossing because its pointing has been prepared. You move with that waiting tilt, not with any rush. The dish has a bearing to hold. The spacecraft has a path to cross. Between them are distance and thinning air. The rest is mathematics, letting a receiver be ready before the first clean contact. Before contact, compatible direct broadcast equipment can already be aimed from the orbital data. The satellite is still beyond the local horizon. The surface path is already being prepared as a direction. Nothing needs to move quickly. A motorized dish can hold its tilt against a frosted horizon. The orbital data turns a future crossing into a track the receiver can follow. That is the calm use of the numbers. They do not need to be shown or read. They only have to place the spacecraft in the sky in time for the dish to meet it. At Svalbard, the agency monitors direct broadcast quality at the monitoring point during at least 3 passes per day for each managed satellite. The northern place becomes a measuring site for the stream. The downlink arrives through polar air, and the check is for the signal rather than for any scene of labor. You are far out now, and the surface lights have become sparse. The Svalbard monitoring is about the quality of the high-rate data stream. An overflight comes over the northern site and enters the local chain. The equipment can treat the arrival as a measurement of the downlink itself. Around the antenna, the landscape remains broad and blue-black. At least 3 passes per day gives the checking a low rhythm. It is recurring contact between satellite and site, repeated for each managed spacecraft. The idea can be held as separate arrivals over a high-latitude station, with long spaces between them and the same receiving point below. The quality monitoring sits inside the wider receiving arrangement. The signal has to arrive cleanly enough to be useful. In that thought, the night-side satellite becomes practical again, an invisible stream tested at the northern edge, inside hardware built for it. You pass beyond that northern check. The receiver room falls behind, then the outside world widens again. Snow and shelter roofs become a pattern under the track. The signal has been followed this far, caught, and measured by waiting equipment. The northern monitoring point belongs to a larger receiving arrangement. The route now keeps moving over the polar arc, from hardware toward named places, spaced through the same prepared system. Each place can appear as a clear point, then settle back into distance. That arrangement uses Svalbard in the north and McMurdo Station in Antarctica. Fairbanks holds the backup role. The NOAA Satellite Operations Facility is in Suitland, and a consolidated backup is in Fairmont. Those prepared places spread the system beyond a single dish. Svalbard is the northern point in that arrangement. Its role fits a polar orbiting system that keeps crossing high latitudes. This point can meet passes where the tracks gather near the top of the world. The view stays spare, dishes and low structures under a frost-white night. McMurdo Station is the Antarctic name in that arrangement. The southern point gives the route its far other end. A dish there faces ice, low cloud, and open distance. The satellite overflight can come down to a place where the continent feels almost without edge. Svalbard and McMurdo Station give this arrangement polar reach at opposite ends. The satellite does not belong to a single hemisphere in this view. It comes over the top, then the bottom, while prepared receiving places wait under separate kinds of night. Fairbanks holds the backup role in the fiscal year 2025 system. The backup word can stay low in the mind. It means another prepared place sits inland under a northern sky. A graphite antenna beside a sheltered equipment chain can wait there within the same arrangement. The Suitland Operations Facility is in the same system. The route shifts away from polar snow for a moment. It enters a controlled equipment room where the far stream can be supported by racks and conduit paths. The place can be seen without faces, only metal, cable, and blue-white pinpoints. A consolidated backup in Fairmont also belongs to the same system. The backup sits there as another prepared place. No alarm belongs to it here. It is a second path held in reserve, a compact facility with cool lights and equipment ready behind the walls. You pass the names as if they were lights on a high, frosted surface. Svalbard becomes the northern point. McMurdo Station settles as the southern one. The backup names recede. Suitland becomes the support point. Each name can now fade into distance, leaving only the route between them. The wider arrangement is larger than one dish. It is a set of places and prepared backups spread between polar reach and inland support. The satellite overflight touches that arrangement as measurements. It slips from space into equipment, then into the weather science the system supports. The named places give the science stream several routes through the site arrangement. Svalbard and McMurdo Station mark the polar reach. The backup sites sit as softer names. The Suitland support site stays on the operations side, where racks can replace landscape in the mind. At this distance from the bed, the world is mostly receiver and route. The earlier moonlit image has thinned into X-band, antenna width, orbital data, and named sites. Yet the motion stays smooth. A single spacecraft crosses overhead, and prepared places below turn that crossing into science measurements. The receiving chain keeps the scale near the surface. An antenna meets the sky. The early radio hardware sits near the captured path. The demodulator and processor carry the stream inward. Those are the named pieces the agency gives, and they make the far satellite feel almost touchable. The sites keep the distance wide. Svalbard and McMurdo Station occupy opposite polar ends inside that reach. The backup rolls sit around it. Suitland stays on the support side. The arrangement feels broad, but each visible thing can stay concrete. A dish beside a dense rack inside a service structure. You move from one prepared place to another, farther across the ground arc. Brightness does not pull at you. The point lights need nothing more. The dishes stand complete. The names have done their work, and the route can keep rising after this, away from receiving shelters. A direct broadcast station is modest beside the planet. It listens under. Its dish can be only a few meters across, and its electronics can sit in a rack or on a bench. The scale stays easy to hold, a weather satellite crossing overhead, met by practical hardware below. The X-band stream remains unseen as it enters the equipment chain. What arrives there is science information, carried as a signal until the electronics make it usable. You pass along that invisible edge, where space becomes cable, and cable becomes a stored record with no glowing surface required. The receiving world becomes stations under different skies. One is northern, one is Antarctic. Another is inland backup. Another is an operations facility. Fairmont holds the consolidated reserve role. The names stay real, but the night turns them into positions on a cool surface, each prepared for its part. You keep moving beyond the dishes now. The metal circles remain behind on polar terrain, tilted toward passes still to come. The signal route has been followed down this far, close to what catches it. From here, the next stretch can rise away from stations and shelter roofs. Direct broadcast still means the satellite can send science measurements straight to compatible receiving sites. That fact now feels like a place. A dish feeding processor hardware inside a compact shelter under polar air. The night crossing has turned practical without becoming hurried. A signal comes down and the receiver is ready. The two named spacecraft have already appeared as data rates and names. Their streams move silently as measured information crossing distance, then entering equipment. The receiver leaves the night spacious. It gives the moving spacecraft a measured doorway. For a while, the last visible thing is only the capture shape. A silver dish, a low shelter. A line from sky to the low building has already carried its measurements inward. The place does not need to explain itself again. It waits under polar night, prepared for another overflight. The land falls lower, and the radio line opens above it again. The prepared receiving world has a final shape before it slips behind. A compatible setup has a dish feeding a receive chain. A processor sits at the inward end. The wider arrangement holds polar places and backups. Together, those facts make a calm ladder from satellite to Earth, technical and blue-white. The polar receivers remain below as objects, not explanations. Dishes keep their upward tilt. Racks keep their pinpoints. The named sites fall into the larger face of Earth. What was once an overflight has turned into a descent path, followed all the way down. You are far from the bed now, held by distance rather than effort. Behind you, polar receivers sit in their own weather and their own night. Ahead, the route opens upward again, away from ground hardware and toward the higher watch above the turning world. Geostationary satellites keep a fixed watch because they orbit above Earth's equator at Earth's rotational speed. That matched motion gives continuous coverage from high over the weather fields below. You rise beyond the old polar sweep into a height where Earth turns under one held gaze. The polar ground arc falls away behind you. Its snow-lit dishes are no longer the nearest things. Above them, the view widens from root to globe, with silver folds spread across it. Your body feels carried by distance rather than speed. The higher you rise, the slower the turning seems beneath your floating weight. At this altitude, the old idea of an overhead crossing loosens. A pass belongs to something moving over a place. Here, the ground itself seems to move below the spacecraft. Storm shields cross the ocean. Coastlines rotate through thin light. You keep rising toward the fixed ring. The atmosphere below is already larger than any single storm shape. It spreads into a rounded field of white tops and night curve. The satellite ahead is only a graphite mark from here. Still, the mark belongs to a precise height. The climb stretches the silence between objects. A spacecraft that looked near now seems suspended on a finer line. Earth stays luminous beneath you, not close enough to touch. The surrounding space takes on more depth with every mile. These satellites operate from geostationary altitude, which the program states as 35,800 kilometers, or 22,300 miles, above Earth's equator. At that distance, the globe fits into a rounded frame. Clouds become texture on a blue-white sphere, framed by graphite space. The number has stopped being a count and become a feeling. Roads and shorelines lose their separate pull. The atmosphere remains visible, but it no longer presses close. You float where scale does the lowering, and the hemisphere rests inside one unbroken arc. The world is smaller than the feeling of it. Its edge glows faintly where air thins into space. White bands keep their silver grain. Your attention has room to hold the whole weather face at once. A near circle forms where the planet meets space. At the limb, blue fades into black. Weather near the center looks broad and slow. Near the rim, the cloud field bends away, half hidden by the planet's edge. You stay with that outline as the view moves farther out. The silver deck has its own scale now. Its bands feel too distant to cross. They lie across the planet like brushed metal, separated by blue water and muted land. Your attention can rest on the whole surface at once. Current operations are a 2-satellite watch. GEO-19 operates as goes east at 75.2 degrees west longitude. The Western spacecraft, GEO-18, holds 137 west. GEO-16 remains the backup. Together, the operational pair holds eastern and western views. The geometry is exact, but the image stays spacious. The eastern position opens over the Atlantic side of the hemisphere. Cloud arcs curl over water before meeting the long bend of land. You pass it as a held window, not as a label. Far below, the ocean carries the light in muted blue. The western position answers with more ocean beneath it. Pacific cloud bands fill the frame before they reach the coast. Nothing in the high ring needs to chase them. At that height, motion becomes a set of slow shapes. Your attention can widen with the water. Between the two fixed views, the planet does not feel divided. It feels held from two angles. The ocean surfaces spread into blue depth, and the white cover gathers along both sides. You pass between those high positions without needing to choose one. The backup point sits apart from the two brighter views. It has the feeling of a reserved place in the high arc. Your path passes the extra shape, then keeps Earth centered below. The spare spacecraft remains in the arrangement without drawing the night toward itself. The Eastern handoff happened on April 7, 2025, when the new Eastern satellite entered operations and replaced GOE SMINUS 16. The date is recent, but the orbital frame makes the transition seem slow. One spacecraft occupies the eastern point, while another settles into reserve. Below them, cloud bands keep crossing the same broad globe. You pass the transition as geometry, not as a burst of activity. A fixed position holds one view. Another waits away from it. Earth beneath them gives the movement its scale, with land and water turning in one rounded field. The change becomes another shape in the altitude. The replaced spacecraft does not need a story around it. It becomes a quieter mark on the same high path. The newer eastern point faces the same clouded planet. Your route keeps moving through the space between them. The series feels like a high balcony over the atmosphere now. Cloud decks fold over sea and land below it. Above it, space opens with fewer marks. You are still moving outward, but the frame has slowed into one circle. The Advanced Baseline Imager, ABI, is the primary Earth viewing instrument in the series. It uses 16 spectral bands that include visible and infrared ranges, with near-infrared between them. Inside the spacecraft, a dense optical assembly divides the globe into several kinds of seeing. The fact stays mechanical, but the result looks like layered weather. Visible light gives the planet one face. Near-infrared gives it another. Infrared gives it another still. Those names can pass through you without becoming a lesson. The same white shield simply gathers different forms as the imager looks down from high orbit. In one band, a coastline may sharpen. In another, cloud tops may take the attention. The instrument's channels keep the same world intact. They let the weather be read in different light. You float beside that layered seeing, as if each band were glass. The glassy layers do not crowd the view. They slide over one planet, each receiving a different part of the light. The imager keeps its aperture turned toward the same rounded Earth, while you continue past the instrument bay. The view remains broad, even when the instrument separates it. A channel is only a way of receiving light. The hemisphere stays whole beneath the sensor. Ocean and white cover keep their rounded arrangement, while the data becomes more detailed. ABI scan modes let the satellite make a full-disk Western Hemisphere image as often as every 5 minutes. In Mode 6, The wide frame can update on a 10-minute cycle, while regional sectors update too. The scan boxes travel across the globe like thin panes over water and cloud. The rounded planet is the widest frame the imager gives you here. Ocean and continent share the image with a white shield and night edge. At this distance, the hemisphere can be held in one thought. Your floating body has room for it. A regional sector narrows the attention without breaking the larger view. It is a chosen pane over one part of the hemisphere. Cloud texture gathers inside it. The rest of Earth remains curved around the frame, wide enough to keep the pace low. The pane can rest over ocean for a while. It can hold a coastline in its cooler light. Mode 6 feels like two rhythms sharing one instrument. The wide image returns on its longer cycle. The regional panes come back between those wider looks. From where you float, the geometry seems almost tidal, a measured return across the same blue-white world. ABI mesoscale sectors can refresh quickly in Mode 6. Both focused domains update every 60 seconds, or one smaller subdomain updates on a half-minute cadence. Those frames gather change from storm tops, while the wider frame remains around them. The boxes appear fine and exact against the broad field. A focused view feels close, even from geostationary height. White tops fill the selected frame like folded fabric seen from high orbit. The satellite stays in its high place, while the chosen field changes beneath it. You receive the speed as pattern, not pressure. The smaller subdomain rests inside a larger sector. It is a window within a window, set over moving vapor. Beyond it, the planet's curve keeps the frame from feeling tight. The selected patch remains within the same hemisphere. The fast updates are folded into height, so they lose their sharpness. 60 seconds becomes one return of the faint rectangle. The shorter cadence brings a smaller crossing within it. The timing belongs to the instrument, while the frame remains a slow field of atmosphere under space. The scan pattern keeps working after your attention has widened. Rectangles cross the hemisphere and become almost transparent. The white field below is still changing, but the high perspective turns change into order. You move past the panes and keep the whole image in mind. The scanning rectangles behind you begin to feel like breath marks. They touch one region, then open back toward the wider view. Nothing in the frame snaps shut. The geometry loosens until it almost blends into the cloud cover. Infrared imagery works at night because the infrared channel senses heat emitted by Earth's surface and atmosphere, including clouds. Visible images need reflected sunlight. In infrared, the unlit side still has form, drawn by heat instead of daylight. Cloud tops appear as layered blue-white shapes against the planet. The night below is not empty from this altitude. It holds temperature structure. Water and land fade under the thermal frame. Higher layers keep their outlines in cooler colors, while lower layers spread more broadly. You pass above it all without needing the sun. After sunset, the image remains useful for a reason you can feel. The atmosphere gives off its own sign. The sensor receives that sign from far away. Daylight has left one side of the disk, but the air still carries its shape. The darker half of Earth grows more legible as you move past it. Heat makes a contour where visible light has faded. White shields become bright islands in the night frame. The instrument keeps receiving without making the scene brighter. The terminator bends across the globe like a wide seam. On one side, visible light can still reflect. On the other, the infrared frame continues. The two halves meet without drama, and the bands pass through the boundary. From this greater distance, thermal differences become a language of layers. Earth gives one tone. Thermal layers and upper air add others. The instrument carries the sorting at the edge of space, and you float with the layered result. The infrared night side begins to recede behind you. It remains visible, but less divided. Cloud top contours turn into one white atmospheric skin. The planet keeps its shape after daylight fades, and the distant sensor keeps receiving what the eye alone would miss. The geostationary lightning mapper was the first operational lightning mapper flown in geostationary orbit. It is a near-infrared detector. From geostationary height, it continuously observes total lightning over the Americas and adjacent oceans. Below the sensor, flashes reduce to tiny blue-white points inside the storm cover. The lightning has no sound from here. It is only light, deep under the high ring. The points appear and fade within larger storm shapes. The globe remains the main object, with each flash held inside a wider curve of cloud and water. The near-infrared eye keeps its attention on the storm cover. It receives flashes without turning the scene bright. You float beyond the scale where thunder could follow. A flash becomes a measured speck, then folds back into the field below. At this distance, even a flashing shield is visually reduced. The mapper does not make it loud. The flashes reduce to fine points within a white cover. The ocean beside it stays wide. The continents stay curved. Your attention keeps spreading outward, past the instrument and past the flashes. The flashes are brief, but the larger view is broad. They appear as points inside storm mass, not as scenes on the ground. The ocean around them remains a sheet of muted blue, and the detector's gaze stays high. The mapper's field stretches across the Americas and nearby oceans. That breadth comes from the same high position above the equator. From your wider remove, its area is a wide reach beneath a fixed spacecraft, not a boundary to solve. You see the imager and the mapper share the same visual world. One turns the globe into bands. The other gathers lightning pinpoints. Both look down from the geostationary ring, where the spacecraft seems nearly motionless against the planet. The spacecraft itself becomes simpler as you move beyond it. A box of instruments, a set of apertures, a fixed angle toward Earth. The world below carries most of the image now, with scan geometry and point light flashes resting on its surface. Apertures and panels lose their hard detail. The spacecraft is still exact, but distance rounds it into a silhouette. Its face remains turned to Earth, while your path opens past its darker side. From here, the globe feels less like a chart and more like atmosphere under glass. The scan geometry thins. The lightning points become grains. The infrared night side stays visible, but it no longer asks to be separated into parts. The round image gathers them into one low frame. The old polar path is far beneath the geostationary ring now. Its motion has become memory in the lower air. This higher system stays with a single planetary face, while your route keeps moving outward. The difference already stands, and it needs no further measuring. You continue outward past the fixed point. The satellite, still facing Earth, recedes behind you. The planet grows smaller, but the atmosphere is still legible. Cloud layers and night warmth gather into one blue-white globe. Space around it takes more of the frame. The scan boxes are fine lines now, almost too light to hold. The lightning points are finer still. The two operational views fall into one wider arrangement behind you. East and west feel less like separate windows now. They become a balanced geometry around the globe. Their longitudes were exact when you passed them. From this distance, exactness turns into placement, and placement turns into a ring around Earth. The backup point is dimmer in memory than in space. It sits in the layout without pulling the eye. The held globe below matters more than the spare shape. You keep rising until all of them fit inside one look. The layered imager and the lightning mapper begin to flatten into shapes. The scan geometry goes with them. Their names loosen. They become instrument outlines behind you, while Earth gathers the rest. The fixed orbit becomes simple again. A satellite sits over the equatorial line. Below it, a weather sphere carries fine rectangles and points of light already behind you. The whole arrangement is high and measured. Beyond geostationary height, the scene loosens. The satellite is now a little graphite mark near Earth. The Americas have stopped feeling like a map to read. They are a muted portion of a round world. You move toward space, where broadcast paths will matter more than instruments. The atmosphere remains below, but it has lost its closeness. Clouds lie on the planet like brushed silver. The unlit side holds its thermal form. Day side keeps a faint brightness at the curve. Both rest on the same globe. You are carried by scale now. The numbers have become distances. Altitude and longitude settle with scan rhythm and spectral band. Detector becomes part of that same map. The pattern is far over the weather fields, fixed above the equator, and already behind you. Looking back, the fixed satellite still faces Earth. The line between spacecraft and cloud deck is simple. One side receives light and heat from the world. The other side opens toward wider space. Your path follows that opening, leaving the steady watch to continue behind you. The distant watch becomes a point. Earth becomes a globe. That sphere becomes atmospheric color in a wider field. You keep moving outward above the cloud tops. The geostationary arc remains behind, holding its measured geometry. Above those fields, the steady watch has thinned to a clean shape against space. The instruments keep facing the planet. You keep moving outward. Below, the globe turns with cloud layers and night warmth. A farther system of paths waits beyond the world. The fixed watch is behind you now, high above the equatorial line. Weather remains below as texture and heat. Ahead, the image will travel on. You float farther from the room, still held by the same sleeping night. GO's rebroadcast is the high-volume direct broadcast route from the geostationary view. It carries full-resolution data that is calibrated and near real-time. Geostationary Lightning Mapper Level 2 data travels with it to users with suitable receivers. Across the night map, the signal spreads into a web instead of a narrow line. The same observation can leave the satellite and arrive as a usable stream beneath broad coverage. The flow is shaped, blue-white, and repeatable. The edges are cool, almost map-like, with no endpoint asking to lead. Your attention rides far above the old room now, thinned into the map light. Coastlines below lose hard edges and become boundaries for signal. The broadcast paths spread in faint arcs, crossing water and land without asking you to choose between them. Your body is only carried through the pattern, loose inside its distance. You can feel the route widening before any new name arrives. The rebroadcast stream uses 2 digital streams at 15.5 Mbps each. The twin channels carry imager and lightning mapper data, with space environment and solar data beside them. The rate sits inside the channel in a cooled equipment view. 2 paths move side by side. They resemble paired blue-white lines held inside the same relay. The spacing stays measured as they leave the equipment view. The paired channels fade into scattered receiver specks beneath the broad night sky. Around those specks, the map leaves room to breathe. A receiver point can be tiny and still belong to the same path. It does not need a visible room around it. this scale, place becomes a pin of light, and the signal becomes the space around the pin. You move with the scattered points for a while. Each point is a place where signal can arrive. A wider map surrounds you, and your body stays loose inside that width. The web carries no voice. Its paths repeat, with thin light and space between them. That gives the mind something to follow. Even the gaps seem useful because they slow the shape down. Before those paths return to the ground, the raw satellite stream has a lower, earlier form. Level 0 data is the unshaped material in this system step. It has not yet become the calibrated products a receiver can use. The route bends toward Wallops, where processing begins. A coastal node appears in the map, cool and still. Wallops receives GOES Level 0 data and creates calibrated products and geostationary lightning mapper level 2 plus products. Then it uplinks packets to the satellite for rebroadcast relay back down to users. The step is circular, but it stays calm. Data comes down, changes form, rises again, and returns as a signal a receiver can catch. The loop closes without becoming urgent. From far away, the circle looks like a slow turn. You pass along that loop without holding its order. Down, formed, up, and down again. That is the whole of it. Somewhere below the coverage, a receiver waits inside the broad spill of signal. Its lamp tiny from here, a cool point under the cone. The packets at Wallops carry the same observation made fit for the broadcast path. Inside a low-lit processing room, fully populated equipment racks can stand like dark furniture. Complete cable bundles turn into shadowed rows. The purpose stays practical. Shape the stream and send packets upward. The room can remain metal and cable with blue pinpoints. The cool rack face holds the packet route by itself. Your body is farther out than the clouds now, carried through packet paths beyond reading. The labels fall away from the map. What remains is motion, repeated until it feels like a dim current under broad coverage. A node brightens, a line lifts, then the whole shape relaxes back into blue-black distance. The current has no splash, only a slow rearrangement of points. The GOES ground system operates at 3 sites in the Weather Agency's satellite service. One is the NOAA Satellite Operations Facility in Suitland. The other 2 are Wallops Command and Data Acquisition Station and the Consolidated Backup Facility. On the map, 3 fixed nodes hold the network. Blue-white routes run between them and keep the path together. The names are precise, then they can soften. They behave like anchor stones in a stream of packets. A named node can lose its letters now. The name has already done its work. A low-lit point on a label-free map holds its place on its own. Around it, the route slides onward toward the next ground site. The point remains cool and exact. The map can keep moving after the letters fade. You float past the point, and the wider pattern stays open around you. Wallops has already shaped the stream in this path, so the map carries it onward as a sight rather than a scene. The coastline becomes only a curve. The packet route keeps a cool geometry, bending between nodes, then lifting back into the broadcast cone. Nothing else needs to gather around it. The line itself is the motion. The map remembers less when the coastline becomes abstract. The Consolidated Backup Facility is the third site in that system. After the name is spoken, it can settle into a single point of light. The broadcast web grows simpler when each place becomes a node. Each node joins the same slow pattern. The map holds all three without crowding the night. A distant receiver gets the result, not the naming. Your half-awake attention passes among the sites without choosing. It follows the faint lines between them. The ground system has become a constellation on land, fixed and sparse, with the weather itself already far below. The places are named, but the names no longer press forward. They recede into spacing. The constellation stays on land while you keep moving outward. Beyond the higher volume path, another channel is meant for user reception. The direct-to-user L-band broadcast from the GOES series is at 1,694.1 megahertz. It has hemispherical coverage from satellites in that series. There is no fee or license requirement to receive it. The permission is practical, and the path remains wide. A receiver inside that coverage belongs to the map without entering a gate. The number has passed, and the ear can let it dissolve. What remains is a path from satellite to receiver, drawn across half the globe. You move under that span as if under a high roof made of signal. The roof is only an image, but it gives the distance a shape your tired mind can hold. The body can pass below it, still far from the room. The L-band path comes straight through, which gives the field its low energy. A receiver inside the broad footprint listens to the signal itself. There is no busy exchange, only a frosted cone and a waiting terminal under it. The equipment can stay anonymous. Its exact place matters less than its place inside the coverage. Its presence is practical, almost mute. NOAA's fee and license statement makes this path feel open without making it large. The permission is simple, but the equipment still belongs to a real receiving place. In the night, that can be a modest terminal, a clean cable run, and a dim processor beside it. The pathway stays practical and low to the ground. The equipment can carry the whole scale by itself. You pass lower now, closer to the receivers than to the satellite. Closer to the receivers, the path feels less like a stream and more like coverage. It spreads across the hemisphere before it touches any terminal. Your mind can stay with the spread itself, a curved presence above blue-black ground, with the technical number already left behind. The direct broadcast is modest compared with the full data stream. The feed has a 400 kbps data rate with selected imagery and charts. It also carries products for remote user terminals. The feed becomes a smaller doorway through the same weather system. It gives chosen pieces, not the whole full-resolution stream. Around that doorway, the night opens wider. A remote terminal can live on selected products and leave the rest upstream. Selected imagery can serve a distant terminal well. A chart can arrive within the slower stream. A product can move through the same narrow channel. The receiver belongs to the night network with less data moving through it. In the mind, the flow becomes easier to hold because it has fewer pieces. Less data makes more open air around the line. Your thoughts thin with the slower channel. Chosen pieces cross the hemisphere, and the rest can remain far upstream. The difference between full and selected begins to read as distance, not decision. The wider path and the narrower path simply divide. Then both fade into the same night. Both remain far above the room, cleanly apart. The 400 kbps path leaves more space around the data. Packets pass with room between them. Faint marks move along a line that stays open, as if the channel itself has slowed the night. The signal is still real. It is just less crowded in the way it reaches a remote terminal. The wide gap between marks joins the lull. Remote user terminals sit beneath the same coverage as other receivers. The modest feed gives them a smaller set of weather products. A narrow channel carries that set like a thread across the map. The line does not need to shine brightly. Its thinness makes it easy to travel. The line is thin enough for a sleepy mind to hold lightly. Deeper in the network, the names become less important than their spacing. A satellite path meets a ground node, then continues toward a receiver point. The system settles into lines and dim endpoints inside the coverage field. The deeper you move, the more the route becomes geometry. It is still weather data, only more distant from the clouds. The source has fallen far behind the signal. You move with that spacing. Your mind can rest on the distance between points, then cross it without effort. The map no longer reads as a list of places. It becomes a field where the same blue-white motion keeps returning. A point appears, a line passes, and the point dims behind you. The named spacecraft remains a fixed point inside this stretch of the network. Its observations can become rooted products, rebroadcast streams, and selected terminal feeds. By now, the name is only a high marker above the paths. Below it, the network keeps its shape in cool lines, leaving the craft almost still in the mind. The marker stays high in thought, while the products move below. The web is abstract, but its pieces stay concrete. A dense rack face can hold the route for a moment. A link arc can carry it onward. A receiver lamp can end the crossing without closing the night. Then the path becomes line again, thin and blue-white against the graphite field. The object and the light trade places slowly. Your attention loosens around the technical names. Each one marked a place, then receded. The outward motion stays simple now. Signal becomes direction. A receiver waits at the end. The endpoint is only a dim point under night. Between points, your thoughts have room to blur. That looseness is allowed this far from the first view. The dim point gives the mind its next crossing. Some receiver points sit as fixed objects in the coverage field. Their exact rooms can fall away. Cool metal and complete cable bundles carry the scale, with a processor light beside them. The broadcast itself stays at the center. It is a route across distance, held by equipment and repeated paths. The line can stay real without becoming busy. The pathway keeps its measured character as you move near it. Tiredness does not change the transmissions. Relays and receiving points remain spread across the footprint, set apart by distance and held together by the signal. The network can be almost empty in places, yet still joined by faint lines. That join is the only pattern left to follow. The faint lines leave room at the edges. At the network's far side, the signal path becomes almost decorative. It is still technical, but the technical parts are few enough to breathe around. A cone descends. A node receives. A line goes on. The longer you follow it, the less it asks to be interpreted. The network becomes spacing more than machinery. At this distance, the web is almost centerless. A node can sit anywhere in the pattern and still feel balanced by the others. The receiving points are more like faint bearings than destinations, marking direction without asking for arrival. GOE-19 is the last satellite in the series. The spacecraft extends the operational system through 2036. The fact lands at the edge of the network, where a name becomes a date. The date becomes a long, unlit corridor ahead, beyond the last receiver light. Those points remain below it, sparse and distant. After 2036, the year can settle. It stretches the operational system farther into the future than tonight. The network remains a set of paths under night, with the named spacecraft fixed as the last member of its series. The date rests as a far marker. It sets range without pulling the mind forward. The marker rests far ahead, but the signal keeps moving here. You are carried past the date as if past a far window. It gives shape to the future, then becomes another point behind you. The broadcast field continues ahead, lower in detail now, wider in scale. Your own sense of direction grows hazier, but the path itself stays drawn. The future marker recedes into the same blue-white field. farthest stretch carries repetition across the data web instead of a new orbit. A stream is processed before a broadcast descends. A receiver catches its share of it. Then the route opens into another span of night. The pattern stays easy, moving on without becoming a puzzle. Every motion has already been softened by distance. The web grows wider, while your thoughts grow less exact and lighter. Below the broad coverage, user receivers remain simple points in the field. Their suitability belongs to equipment and reception. The broadcast arrives where a terminal is ready, while the rest of the night stays broad around the point of light. Nothing in the line hurries. The cone can widen, and the point can wait. The wide cone gives the terminal all the sky it needs. The ground sites are far behind the signal now. Their names have served their purpose, and their shapes have become nodes. From here, the network is mostly spacing. A frosted cone and a thin channel with a receiver light beyond them. The exact geography softens, while the connections remain visible. You move through that distance with almost nothing to solve. The facts have become placements. Those marks become a route, and the route keeps carrying you farther across the weather network. The mind can follow the thin geometry without holding every name. Knowing the route goes on is all that matters here. Your attention can be less precise. The last visible receivers sit beneath the satellite spill. They mark the outer edge of this data path. Each light is a terminal place where a broadcast can settle into equipment. After the long route through satellite and ground, the network reaches a quieter edge where only the arrivals remain. That is all that is needed. The system behind them can blur. Your body feels very far out, but the motion stays low and even. Fewer names remain on the map now. It is mostly faint geometry and blue-black space, with signal crossing slowly. The technical shapes have become almost weightless. They move around you without needing a decision. The outer edge has become almost all spacing. Beyond the last receiver light, the broadcast web thins into the hemisphere. The named places have become points already passed. Here, the data paths remain far out. They spread wide while staying almost weightless. You keep floating through their blue-white hush, with the weather far below and the signal still moving. The distance can hold you a little farther out. The wide forecast map begins to loosen its grip as you travel back toward home. The old scale loosens before any new thought can form. The routes have stopped being puzzles. They are blue-white paths on a sleeping planet, with clouds gathered above roofs and water. Your attention comes home by degrees. The screen seems lower now, as if the last bright margin has been folded down for the night. The far web has started to feel domestic again. Each Polar Fleet satellite carries at least 4 core instruments. The 4 are the Advanced Technology Microwave Sounder and the cross-track infrared sounder. The visible infrared imaging radiometer suite and the ozone mapping and profiler suite complete that core set. Some missions also carry clouds and the Earth's Radiant Energy System, or Libera, for Earth's energy budget. The names can rest as an instrument set now, not a lesson. Each label can stay closed in its own cool slot. They sit in cool order, like tools packed inside a craft that has already turned its attention back to Earth. The closed set is complete. You pass the instrument set as you would pass shelves in a dim room. The terms sit closed. They stay in a neat row in memory, each attached to a way of noticing the planet. The roomward pull is stronger than the sequence, and the sequence becomes background. You leave the precise work inside the cool case. The current polar fleet includes Suomi NPP, NOA Amanus 20, and NOA Amanus 21 in the flying fleet. JPS-3 and JPS-4 remain upcoming satellites, with JPS-4 slated for launch in 2027. Present craft and future craft sit beside each other in the mind, outside any diagram. The order passes like beads on a string, then stills. The sky has room for both the named and the not yet launched. The bed receives the low fact of sequence. Those names pass behind you and lose their edges. The satellites already in orbit have their places. The coming ones can stay farther along the schedule. You follow the lower light toward home until the forecast is only local conditions beside the glass. The remaining trace rests there. That future date can remain outside the room. GOE-18 replaced GOE-17 as operational goes west on January 4, 2023. GOE-16 now sits at 100 and 4.7 degrees west as the on-orbit standby. The fixed arc feels spare here. It is a scatter of settled positions above a muted hemisphere, far from the pillow, yet already turning homeward in your attention. It feels less like news than arrangement. That standby word can pass through you without weight. It stays spare. It is a place held as backup, high over clouds that may be crossing your roof. The spare roll belongs to the sky, far from your pillow. Home keeps coming nearer, carried by a dimness that has almost stopped explaining itself. The term stays distant, like a reserved key in orbit. NOA Amanus 21 became fully operational on November 8, 2023. The finer roll wording can be left out of the bedroom. A finished fact is all this late hour needs. The date settles. The label loosens. The satellite returns to being a point above clouds, and that point returns to the muted map. The secondary labels remain elsewhere. After that, the sequence begins to fade into sky again. You are closer to home now. Clouds remain, spread thinly over the night like breath on cool glass. The atmosphere above you is still being observed from far away. That is the last clean outline of the machinery. Over the roof, an unseen satellite frame keeps the clouds inside a larger planet. Coastlines and water hold their shapes under blue-white night, while your attention turns back toward the nearer window. Nothing in that frame presses closer. The sight is wide, and you are narrowing toward home. You move beneath that larger view, and your gaze can stay low. The ceiling is near. The blanket is near. The screen light sits apart from you now, less like a map than a forecast remembered by glass. It carries the end of a long path without pulling the path back. Even the ceiling seems to receive it faintly. The travel has shrunk to a room-sized remainder. Farther out, the satellites keep their distances. Their names have become positions, and their positions have become the faint order behind a forecast. The instruments have stopped being a mechanism to follow. They are a cooled shelf of attention, turned toward the broad atmosphere below, while you keep sliding inward through the lowered result. A forecast can carry order without reopening the craft. No part of it needs to be unfolded. The forecast near your pillow is a lowered result now. It arrives after orbit has done its work. It is just the shape of local conditions, smoothed by distance before it reaches home. The high names remain high, and the bedroom takes in the night in a low register. It comes down as usefulness, not instruction. The result stands on its own, and the source can stay remote. The forecast reaches you as a low, wordless light beside the bed tonight. Outside the bedroom, the same conditions belong to a much wider layer. The breadth has no hurry in it. It crosses roofs and unlit roads before a screen makes it legible. From high overhead, that moving layer is simply part of Earth, broad and slow beneath the satellites. From here, it is the coolness at the window and the weight of the blanket. The wide layer turns personal only at the last moment. Your attention can leave those roads alone. It can rest on the curtain hem near the dim rectangle. The far system has thinned to a household sign, a low sheen that says the sky has been gathered. The rectangle can stay unnamed. Sorting can wait beyond that sheen. This is a sign, not a subject. The gathered forecast has no sharp corner left in it. A satellite name may sit somewhere behind the image, but the bedroom accepts cloud and temperature as a muted surface. That field can remain unread. The machinery turns remote, and distance turns into hush. Knowing it was seen is plenty for this hour. The proof is present, but its outline has blurred. You are close now, and the bed has become the main fact. The sheets hold their folds. The pillow holds its shadow. Outside, the sky remains broad. Inside, night narrows around your rest. The bedroom shape is simple. The far observing has turned into the feel of covered warmth. Home is arriving as texture, not explanation. Above that narrow place, cloud shapes continue across the larger map. Orbit notices them with lowered drama. The same observation that once felt technical now has the pace of a curtain moving in the low room. The map does not pull you back out. It only stays broad, easy to leave alone. The outward part is finished. The bedroom curtain barely changes. It holds the amber house edge and the cooler light from the screen. Between those colors, your thoughts can pass like mist through a valley, losing detail as they go. The far names thin first, then the lines and boundaries slacken too. A pattern leaves last, like ink underwater. Even memory of the grid starts to loosen. The satellite record behind the low light is now a long, remote noticing. A sensor looks down. A map is made. The result arrives with its borders already muted for a room that is nearly still. By the time it reaches you, it feels almost domestic. The process can stay upstream. It arrives without the sharpness of its making. Nearly still is all there is now. Your body has the weight of bedding around it. The window has its faint square of night. The world beyond can stay broad and named elsewhere, while here it becomes coolness at the pane. The bedroom holds the nearby part without naming the rest. The rest can wait at its own scale. The named world can remain beyond the glass. Elsewhere is not very far in the finished map. The far view narrows into a nearby patch of coolness. It settles into the bedroom. Nothing hurries across that fold. It moves slowly, easy to forget, while it remains true. The screen can dim, and the fact can remain. Truth can be faint and still be held. That narrowing carries the return. Clouds pass outside, and the bed stays close, holding on to everything tonight. The far satellites return as shade and breath near the pillow. The sky is above you and across the wider night, named in records and colored on the map. All the machinery folds away from home. Indoors, only the felt part remains. You can let the names remain in the records. Nearer nouns belong here, sheet and window. Outside remains measured elsewhere. Near you, the scale is fabric and shadow, and the forecast is a faint trace around the house. The record keeps its terms elsewhere. The hard names have done their work. A map can cover a hemisphere, then arrive as a light no larger than a book. The change is a narrowing into usefulness. It is how distance becomes useful indoors, after the observing is done high over your roofline. The great view has narrowed until it can sit beside a bed. Usefulness arrives without asking to be studied. The last distance is measured by dimness, not miles. The low light keeps the forecast present. It does not pull you outward again. It sits low indoors, duller than the window. The high views and ordered names recede into a background your mind can stop sorting. The world beyond turns to a surface. Only that muted layer reaches the bed, it has no lesson left on it. Far overhead, the observing continues without becoming a story. The satellites are placed objects with instruments and names. From this distance, even those particulars flatten into faint marks above the atmosphere. Their placement is plenty, and the cloud below is plenty too. The high order stays distant. Distance makes the particulars mild. Your bedroom takes in the end of the chain as coolness near the bed. What came before can stay out in the upper atmosphere, where the blue-white path runs wide and blurs at the edge. You are under it, not inside its machinery. The roof becomes the nearest boundary. That line gives the night its shape. No diagram has to cross that boundary. The clouds on the map are muted now. Their shapes look like linted cloth, though they belong to air over the roofline. The satellite image has crossed back into household scale, leaving only a frosted surface where a system used to be. That field softens, then settles. The household scale absorbs it without display. The old diagram turns to texture. The bed answers with its own map. A wrinkle runs beside another wrinkle. A fold meets the pillow. Nothing is labeled, and nothing needs to be. The room's climate is the touch of covered warmth against your face, and the slight cool place where the blanket lifts. This is weather without a label. Beyond the window, the larger system keeps moving through its own layers. It may become cloud on a map, shade in a forecast, or a faint smear on a screen. Here, the exact source has faded behind the low proof that the sky was measured. That evidence is faint. Home is nearer. The measurement can remain behind the glass. The source remains remote. The satellites remain far enough away to be simple. The agency can keep their names in order. The sky can hold its clouds. Indoors, the exterior becomes a dim suggestion, neither diagram nor lesson, just conditions translated into a lower light. That dimness can do that. The translation asks for no answer. It rests at the threshold of attention. You are back among nearby things. The curtain edge, the water glass, the shallow hollow in the pillow. Air around these objects still belongs to the same broad observation. The bedroom has taken the sharpness out of the fact. It leaves only nearness. Near objects ask for less language. The close scale does the last editing. In the orbital frame, clouds cover land and water without caring about rooms. Near the bed, those clouds become the reason for a faint icon, a gray patch, a cooler window. The fact has crossed a great distance, then settled into almost nothing. Such a small result fits the bedroom. The ending has the size of a breath. The room accepts that smaller scale. Almost nothing is the right size for sleep. It is just a low light near a pane, with fabric gathered below. The satellites can remain at their height. The exterior can remain beyond the walls. The bedroom keeps the trace that belongs near your breathing. That close presence is what matters. The machinery is elsewhere. The last traces of the instrument set are now only tone and placement. A satellite name becomes a dot. A hard name becomes a cooled shape inside a larger craft. The map becomes breath. That outside layer lowers into the room's edge of night. Only tone can safely leave. The names have become color. Your thoughts can follow that border for a little while, then stop before it turns technical. The bed becomes the nearest geography. The blanket is its climate. The pillow is a low hill under amber shade. Beyond the wall, the real atmosphere keeps its own shape. It does not shrink because home has grown nearer. The far observations continue as far observations, but their meaning here is simple. Weather exists above the bed, and it has been seen. The wall does not divide the truth. That sentence can settle without becoming larger. It is a modest truth for the pillow. Seen from far away, then muted here, it becomes a background you can leave unopened. The screen is dim. The window is darker. The answer settles into temperature. The coolness beside you has no sharp sound. It is a change in temperature, a colder place at the pane, a faint difference under the blanket. The sky may be measured from high overhead. Here it arrives as almost a feeling. That sensation has no edge. A faint trace is plenty. It stays low, settled for rest. Nothing more has to be added to the map. The far names have receded into distance. The exact parts have gone back inside their craft. The cloud shapes have lost their borders, and the bedroom has kept only the air that can touch you. Contact is the final translation. The thought can almost disappear. The screen can remain a dim pane. That low rectangle can be left behind the eyelids, though the bedroom stays exactly where it is. Outside, clouds cross the roof. Above them, the satellites remain far enough away to be simple. The remaining light is almost finished. No fresh detail needs to wake it. Home is not a summary of the sky. It is where the sky becomes air at the window and weight in the bedding. The broad map has grown quiet at the margin of your attention. What remains is glass and coolness resting near you. The final fact has lost its corners. The room finishes the rest by being close. You are back home now. The window holds the night. The bed carries you. High overhead, those satellites keep their wide places. The air over this room remains known from a distance. You are home, under a sky that has already been gathered. Nothing in it asks to be followed farther. The return has made the far sky simple.